Goodbye, Cookie. So, of all the important things in the world that makes the internet tick and the things that everyone loves tick, what's probably the most prevalent thing on the internet? Not porn, but the Linux kernel. The Linux kernel backs like the whole internet and a lot of things, including smartphones and stuff that way. So now all of a sudden, DARPA, or the military, wants to understand the Linux kernel because they haven't really taken time to explore or understand it. They don't know, like, I guess the difference. They're probably running on a standard kernel rather than a hardened kernel, of all things. But yeah. So I kind of read through this article already, so I knew what was up. So the first part kind of goes over, like, the background of, like, the Linux kernel runs everything. DARPA doesn't understand it, so DARPA's contracting with companies to research it, look at the security holes, like bad actors, trying to figure out, like, because we've seen in the past where different projects that the whole entire internet runs on has had malicious code put into it at different points. You look at Node and some of the larger libraries in there when malicious code was put in that deleted files and replaced it with certain messages of anti-war, apparently, and what the kind of damage that it did there. And so, understandably, the military wants to mitigate those risks in cybersecurity, and you've also got, like, different actors like Huawei contributing to the kernel heavily as well. And they're not sure about the code, what is it? Code review process that goes through as to what gets accepted into the kernel and what doesn't. And with how monolithic the kernel is, there's a lot to sift through. So that's kind of more covered in the threats to open sources. A lot of time, it can sometimes be hard to understand the motivation of the actors that are adding code into it. So where is it? Let's see, they call them hackers, have quietly inserted malicious code in open source projects numerous times in recent years. In some cases, these are the individual maintainers adding malicious code, but if the maintainer or the project maintainers are properly reviewing code and looking at it, and depending on the project, they are more security-minded, then they are looking out for those pieces of code that are malicious and that people don't always look at. And so you kind of have to judge who you trust based on that. They also look at different aspects of, like, there are some projects that are maintained by one or two people, and where is it? That's later on, I think. Yeah. But of course, you're worried about these one or two if there's, like, one maintainer for a code project that, where are they from? How's that going to help? You kind of see the same thing with Russia, where they forwent some of the standard security certification processes that most of the other world uses for, like, online certifications and stuff, and created their own certifying authority because they're not sure who they can trust. And the military is starting to U.S. military is starting to realize, what? That's a thing. Okay. When was this put out? Yeah, July 14th, just about a week ago as of recording this. But yeah, so there are a couple threats that you have to worry about and try and worry about mitigating. I mean, untrustworthy code, it's like, hopefully the maintainer isn't doing something, but if sometimes even maintainers that you long trust can sometimes flip out of nowhere, just like we saw with some of the Node projects and other things too. So later on in here, yeah, fragile infrastructure. So we've seen exploits with the Linux kernel that have been in it for quite a while, and there are forks of the kernel that harden against those threats that aren't exactly addressed in the kernel itself. So if you're using the right kernel, then you worry less about it, but you're still worried about it to some extent. You using some of the hardened kernels, you decrease the threat surface that you have, and therefore you can focus more attention on the open surfaces that are there, rather than the one having to worry about one that is less hardened and having to cover more ground with the same amount of resources. You're able to put more resources into one area because you don't have to think as much about the other areas that are less of a threat. There was the bus scenario. Yeah, they don't quite understand because the open source movement, they said it up here. It is, let's see. It is one of the grandest enterprises in human history. This is literally a bunch of volunteers coming together, and for one reason or another, they either funnel money in or lines of code in and create this piece of software that we all now rely on. And what is it? They said in here... And they have it in here that I think it was about, even proprietary software a lot of times, about 70% of it is, open source code. So it's backed by open source code, but they write their own proprietary code on top of these open source libraries. And many times they're actually free software libraries, not just open source. So, and they're worried about, because with the Linux kernel, there are various companies that have been sanctioned by the US government, and so it's like they're contributing to this thing. Now, if the maintainers of the kernel are keeping with the mission or the vision of the project, then keeping it free means that you're also keeping it free of these threat backdoors as much as possible, and you're working to do that. And so that's can be a long review process, and so that you've got these core maintainers that double check the code, review it, and then merge it in, and these companies have to submit the code for review. So to some extent, yes, you do have that layer of like, these people are able to curate through the code, well, this part doesn't quite line up, why do you need this part, and how do we make it so that the kernel is free and it fits with our vision, basically. So if you've got someone that wants to keep things private and secure, then they're going to be able to do that without having the back door in it. And it takes someone forking the kernel and creating their own OS from it, like North Korea, in order to add those backdoors in because it's not built into the kernel. So I think that's what they're worried about, and they don't quite understand that, so they need to learn more about that inside the agency itself, rather than contract out to someone else to worry about that. They teach them how to do it. See, here it is. It's actually 70% or more open source. So, yeah, they don't have a good grip on it. They don't understand the concepts. They've always worked with companies to do their thing, and even, what was it? I don't remember who it was, but I was reading somewhere that even the Linux kernel, this like mainline kernel, is more secure than Mac OS and Windows. And those are closed sourced projects. And part of that can be chalked up to the way that people are able to find vulnerabilities in the field, and then oftentimes they either have someone that, and they can patch it rather quickly with a large amount of people contributing to it, and then get it merged in pretty quickly if it's a critical security update that they need. If you enjoyed the video, be sure to leave a like, comment, subscribe, share the video. Algorithm really seems to like that, and it actually helps it get directly out to more people. And you can even join the chat and interact when I'm not online or what have you, in Discord, Guilded, XMPP, and check out my my streaming stuff. Links are all in the description places, and I will see you guys later.